One more problem on the divisibility. A problem is prove that if n is odd, then n square minus 1 is divisible by 8. That is, this n is odd is given, and we have to prove n square minus 1 is divisible by 8. And second one is if x and y are odd, then prove that x square plus y square is even, but not divisible by 4. So the proof of the first example, that if n is odd, then n square minus 1 is divisible by 8. Suppose n is odd, we assume that n is odd, and we know that any odd integer is expressed in the form 2k minus 1 or 2k plus 1, where k is any integer. For example, 3 is odd. So how we can write 3 as 2 into 1 plus 1, or 2 into 2 minus 1. That is odd integer 3 expressed in this form, 2k minus 1 or 2k plus 1. And the even integer expressed in the form 2k. Okay, that is the even integer, multiples of 2. And the odd integer, the format of odd integer is what? 2k minus 1 or 2k plus 1. Every integer, odd integer expressed in this form. For example, 9 is odd integer. How we can write 9 in this form? 2 into 4, 2 into 5, that is 10, minus 1, that is 9. We can also write 9 in the form 2 into 4 plus 1. So odd integer expressed in the form 2k minus 1. Suppose here n is odd, therefore suppose n is 2k minus 1 for some k belongs to z. K is integer. Then what is the value of n square minus 1? That is 2k minus 1 bracket square minus 1. This is the value of n, 2k minus 1. Then it's square, 4k square minus 4k plus 1 minus 1. Then what do we have? The answer 4k minus 4k square minus 4k. And take 4k as common, plus minus 1 becomes 0. Take 4k as common. Then what do we have? We have in the bracket k minus 1. And what is about this k and k minus 1? K is integer and k minus 1 is its successive integer. These are the consecutive integers or successive integers. That is, these integers are what? Suppose k is 4, then k minus 1, that is 3. Suppose k is 5, then k minus 1 is 4. That is 4 and 5, or 3 and 4. These are the successive integer or conjugate integers. And if we multiply any two conjugate integer, it is an even number. It is divisible by 2. For example, 3 and 2. What is the multiplication? Is 6. That is divisible by 2. Is multiple of 2. If we take k as 5, then k minus 1 is 4, and 5 into 4 is 20. That is again divisible by 2, or is multiple of 2. That is in a multiplication of any two consecutive integers or successive integer is divisible by 2, is multiple of 2, or is even number. And that's why this k into k minus 1 is divisible by 2, means it expressed in the form 2 into some integer. We write k into k minus 1 as 2k1 for some k1 belongs to z, because k into k minus 1 is divisible by 2, means 2 divides to this number, means this number k into k minus 1 expressed in the form 2 into some integer, 2 into k1. And therefore n square minus 1 becomes this value of this k into k minus 1. Substitute that value is 2k1. Then what we have? We have the answer 8k1. So n square minus 1 expressed in the form n into k1, and k1 is integer, and that's why 8 divides to n square minus 1 by using the definition of divisibility. So what is the definition of divisibility? This is the definition of divisibility, that when we say a divides to b, if b expressed in the form, when we say a divides to b, if b expressed in the form a into some integer, and vice versa. That is, if we express b as a into k, then we say that a divides to b, or k divides to b. For example, why 2 divides to 8? Because 8 expressed in the form 2 into some integer. But 2 does not divide to 9, because we cannot write 9 as 2 into some integer. This 4.5 is not integer. 2 into 4.5 is 9, but this 4.5 is not integer. And that's why 2 does not divide to 9. So this is the definition of divisibility. If the number expressed in the form, that is b expressed in the form a into k, or some k belongs to z, then we say a divides to b. So here n square minus expressed in the form 8 into some integer means 8 divides to n square minus 1. This is the proof of the first. Then we have to show if x and y are odd, that is, these both x and y are odd, that is, this x and y are what? This x and y expressed in the form 2 into 2k minus 1 or 2k plus 1. So write x as 2k1 minus 1, and write y as 2k2 minus 2 minus 1. Take k1 and k2 as two integers. because these x and y both are odd. Don't take the same notation, that is here is also k and here is also k, because this k1 and k2 depends on x and y. Suppose x is 9, then this k is what? Is 5. Suppose y is 4, y is odd, means suppose y is 5, then this k2 is 3, because 3 into 2, 6 minus 1 is 5. So if x and y are two different odd integers, and that's why these k1 and k2 are different. And so we take here is k1 notation, where is k2 notation. So x and y are odd, therefore we can take x and y in the form 2k minus 1 and 2k1 minus 1 and 2k2 minus 1. Okay, so we have to show x square plus y square is even. First we have to show x square plus y square is even. So take x square plus y square, then write value of x is 2k1 minus 1, value of y is 2k2 minus 1, and square is this, and this plus 1 and plus 1 becomes plus 2. And if we take 2 common from these 3, then what we have? 2 in bracket 2k1 k1 minus 1, 2k2 k2 minus 1 plus 1. That is, we have x square plus y square is expressed in the form 2 into some integer, and therefore 2 divides to x square plus y square, or x square plus y square is even integer because it is multiple of 2, because if you take 2 as common from this bracket, from these 3 quantities. Okay, and therefore x square plus y square is even. When we say that integer is even, if it is multiple of 2, or 2 divides to that integer. So we have x square plus y square as a multiple of 2, and therefore x square plus y square is even. But we have to also show it is, but x square plus y square is not divisible by 4. The proof is by contradiction method. We assume that x square plus y square is divisible by 4. We assume that x square plus y square is divisible by 4. Then what we have? X square plus y square is expressed in the form 4 into some integer by using definition of divisibility. 4 divides to this number, or x square plus y square is divisible by 4, means x square plus y square expressed in the form 4 into some integer, and take k as any integer. Okay, then substitute the value of this x square plus y square here, 4k, x square plus y square as 4k. Then what do we have? This value of 2 is what? 4k. This value of x square plus y square is 4k, minus this 4k into k minus 1 in bracket k into k2 into k2 minus 1. So write here the value of x square plus y square as 4k, and find the value of 2 by shifting this quantity to left side and changing the sides. What we have? 2 is equal to 4k minus 4k into k minus 1, k1 into k1 minus 1 plus k2 into k2 minus 1. And then take 4 from these two quantity, common 4. Then what we have? 4 in bracket, we have the quantity k and this bracket, and that is the bracket is the integer. Means what we have to express in the form 4 into some integer, and this implies 4 divides to 2, but this is contradiction. This is impossible that 4 divides to 2. And why this contradiction arise? Because our assumption is wrong that x square plus y square is divisible by 4, and therefore what do we have? X square plus y square is not divisible by 4. Here we have x square plus y square is even integer, so aggregate sentence is what? X square plus y square is even integer but not divisible by 4. Then these are some problems on the divisibility. So solve all these problems.